Hello viewers and my dear students. Welcome to Problem 2 Session 1, that is Demo on CNC Manual part programming for a basic milling profile involving contouring and circular pocketing using Demo-Fanuc Milling Simulation software. These are offline video help files prepared by me, Dr. B. Gurudas, former professor and head, Department of Mechanical Engineering, Bangalore Institute of Technology, KR Road, Bangalore 4, presently working as professor at the Department of Mechanical Engineering, Nityam Meenakshi Institute of Technology, Alanka, Bangalore 64. Now, as I said here, you see here, what exactly I'll be doing in this here, in the first part, that is, in the first session, what I'm going to do now, I'll be explaining only the G&M codes, that is the programming part. Programming part, given a profile, how the programming has to be done using, using G&M codes. How the programming has to be done using G&M codes for a typical milling profile, this I'll be doing. In the session 2, for the same program, whether it is correct or not, we will be checking it using Fanuc Milling Simulation software. Now, as I said, in this session 1, I will be explaining you with G&M codes, that is programming of this typical milling profile. If given a milling profile, how the programming has to be done using G&M codes, I will be telling it to you. See here, this is the typical milling profile. You see here, given one milling profile here. The profile is this, and there is one profile here also, one arc profile and all that is that. That means the tool has to go along this profile. Okay, this is 60 mm square, and after that, this is an arc profile of the radius 60. This is an arc profile of radius 50. This is an arc profile of radius 60. This is an arc profile of radius 50. Okay, now as soon as this problem is given, you just see. For the contouring operation, they have said use, you see here, if you see here, use 4 mm diameter slot cutter for the contouring operation. That means 4 mm diameter slot cutter you have to use for all this. That is for the contouring operation and all that, where the tool goes only along the profile. Okay. And 8 mm diameter vertical milling cutter for the pocketing operation. This is the pocketing operation. This can be of any diameter. Please understand, this can be of any diameter. This is now here are given circular pocket 24 mm diameter. 24 mm diameter. I'm using 8 mm. That means the tool from the center, it goes in a spiral way, it goes on cutting till you get 24 mm fold. Okay, a big fold. It can be 24 mm fold or 48 mm fold or 60 mm fold. Whatever it is, the cycle automatically does. That means if you write a correct program, it can do any circular pocket. That means this circular pocket right now has a 24 mm diameter and it should be done in 2 mm quick increment. First it will do a 24 mm diameter pocket, that means with 2 mm depth. Then it will do another 2 mm so that totally this fold will have a 4 mm depth of cut. Okay, 4 mm depth of cut. This fold will have 4 mm depth of cut. Now you see here. See here, this you please understand. This manual part program I will start. This is a thing here. This will be the billet. Along that, can you see this? This profile is this arc profile and all that. I have got this arc profile, arc profile, arc profile, arc profile. This is how you should get. This I'll show you how to get in the simulate. That is in session 2. How to get using Fanuc simulation software, Fanuc Milling Simulation software. Now you see here. For this profiling is this and circular pocketing is this. That is fold of diameter 24 and fold of diameter 24. Directly you can't give 4 mm depth of cut. I've given it in installments of 2. You can give it in installment of 1, 2, 3, 4 and all that. It might take little more time depending on the workpiece and all that. We decide the depth of cut. Here I have decided the depth of cut to be 2 mm. 2 mm once, then 4 mm. These things you'll clearly understand in the simulation part. Okay. Now you see here. Given the profile, you name A, B, C, D. This is 0, 0. This is 60, 0. This is 60, 60. This is 0, 60. Then the G&M codes, since it's a 3-axis vertical milling machine, going along this is X, going like this is Y. Okay. Going like this is X, going like this is Y, and the tool coming vertically down is Z. Okay. Now you see here. Now the manual part programming, I'll just begin. See, carefully, this A, B, C, D are given the coordinates, and also you know very well, G and M codes, okay. G codes will describe the machine tool movement. Let us say you want to move from A to B, you are using G01. B to C, linear interpolation, no, again G01. C to D, again linear interpolation, G01. D to A, linear interpolation, again G01. Then once you are going along the R path, you see this is anti-clockwise. We use G03. G03 to do this, again G03, G03, G03. In that way, the entire profiling is done. Okay. As you know, when you are doing G03, you should give the radius. From here to here, I'll give radius 50. From here to here, I'll give radius 60. From here, radius 50. From here, radius 60. Okay. Now, as you see here, you carefully observe. First, billet you define. X60, X160, Y160. That is, this is billet X160, Y160. And Z is 30. Thickness is 30. You define. Tool definition T1, D04 means for the profiling part. Okay. For the profiling part and all that, I am using diameter 4. That means the slot width will be throughout in the contouring operation, the slot width will be 4 mm. And tool definition T2, D08. That means for cutting this pocket, the 24 mm diameter pocket, I am using 8 mm vertical milling cutter to cut that. Okay. And then you see here, this is G91, G28, X0, Y0, Z0. You have to compulsorily give, because if the tool is somewhere in between, first it has to sense the home position. It will go to the home position. Can you see that H I written? It will go to the tool, will go to the home position first. Okay. M06, T01, 01. That means I have called the first tool 0101, which is of 4 diameter 4. And for the profiling operation, I have taken the speed M03 is 1200. I changed the speed to 1200. Okay. 1200 is the speed for profiling operation. That is A, B, C, D and 4 arcs and all that. I will be doing at 1200. G90. Be careful. This is absolute positioning system. All with reference to A, I will be doing the program. Okay. All with reference to A. This is 00. Okay. A, B, C, D, all coordinates have been calculated from a common origin. That is why G90, it has to be done. Otherwise, your program will be incorrect. Okay. Now you see here. G00, X0, Y0, Z20 means from the home position. G00 means rapid traverse of the tool. The tool from the home position comes rapidly to the position A, and Z20. That means this is Z0. That means surface of the datum is Z0. That means 20 mm above the workpiece, the tool will be standing. It comes rapidly from the home position to position A, but it won't touch the workpiece. It is 20 mm above the surface of the workpiece. Z equal to 0 means it will be just touching the workpiece. In case Z equal to -2, it goes inside the workpiece by -2 mm. That is the idea, what you should know. Okay. Now you see here, G00, X0, Y0, Z20 means tool moving to A rapidly 20 mm above the datum. Okay. Now you see here, once it is that, G01, X0, Y0, Z minus 0.5 you see. That means Z minus 0.5 means it has gone inside the workpiece by 0.5. Z0 means surface. Z minus 0.5 means it has gone inside the surface by 0.5 mm. That means now the contouring will start. That is the profiling or slot cutting will start. Minus 0.5. Feed is 30 millimeter per minute. That is feed 30 means here I have given feed 30 means 30 millimeter per minute. Here I have given inside the workpiece at A. Okay. Then G01 X60 Y0 it goes to B. G01 X60 Y0 feed is 30 because if I not given feed 30 only you take X60 Y0. Then G01 X60 Y60 it goes to C. G01 X0 Y60 it goes to D. G01 X0 Y0 it comes back to A. Okay, comes back to A. Then you see here, this is G03. G03, this is X60. X60 Y0 radius 50. Okay, this is radius 50 you see. G03 X60 that is this point A to B in a curved way. Okay, G03 X60 Y0 radius 50. Then from here to here, see, going to see. G03 X60 Y60 radius 60. This is radius 60. Okay. Please remember that this is radius 60. In the same way, G03 X0 Y60 radius 50 means coming to this with a radius of 50. Then G03 X0 Y0 radius 60 means coming back to D. That means it has done the profile already with these commands. Once this has been done, you see here G00 Z20. Rapidly the tool will move 20 mm above the surface of the workpiece. That means tool rises 20 mm above the datum rapidly. Then I'll send this tool to the home position. G91, G28, X0, Y0, Z0. It goes to the home position. Okay, once it goes to the home position, you see here, I'll call the next tool M06 T0202. This is 8 mm. As I've told you, it is 8 mm vertical milling cutter. And the speed I'll give 1000. G90 again because common origin. Okay, that is the thing. Common origin from origin A. I have named all the coordinates and all. G90 you must do because it is absolute position system. It is from common origin A. I calculated all the dimensions. Now you see here for cutting this fold, please understand, cutting this fold, which is called circular pocket. Okay, in the technical term used in milling is okay circular pocket. We have to use two blocks G170, G171. Okay, now you see here the tool has come X0, Y0, Z10. That means it is somewhere here at a height of 10 mm. Now G170 you remember G170, 171 will define the circular pocket. Okay, this R0, these things you have to remember. R0 is the surface of the job. R0, that means it has to work from the surface of the job. R0. P0 is a roughing cycle. Remember, P0 is a roughing cycle. P1 is a finishing cycle. Don't worry about that. Now it is a roughing cycle. Q2 is the peck increment. That means every time it will cut by 2 mm. X30, Y30, be careful. From this, X30, Y30 will define where you have to do the pocketing. If X30, Y30, since it is 60, this pocketing will be done at the center. If I do X60, Y60, this pocketing will be done at this place. Okay, that is why X30, Y30 will define the position of the pocket. This is very important. Where you want to do the pocket. X30, Y30, this is the thing. Z minus 4 is the depth of cut. How much depth of cut you have to do? You have to do. I0, J0, you put it as 0 because it is a roughing cycle. First it will cut 2, next it will cut 4, no alliances left. Directly it will do. That's why it's a roughing pocket, no alliances left. I0, J0, that is no base alliances, no side alliances also. I0, J0 you take. K minus 12 means it is the radius of the pocket. Now it is 24 mm, no? K minus 12, that is radius is 12, minus 12 or plus 12. Minus 12 means the tool will move in the anti-clockwise direction in a spiral path. Plus 12 means it moves in a clockwise direction in a spiral path. Okay, K minus 12. G171 is another block. What you have to remember? These things you remember. P75. That means the percentage of overlap between the first movement of the tool and second movement of the tool will be overlapping will be 25%. 25% overlap. If I give P50, 50% overlap will be there. A little better finish you get. See here, these commands, you just look at this. I have given these commands here. See here. G170 block, whatever I have told you, I have given. K defines the radius of the pocket and all that. And G171 also I have given. Okay, P defines the cut width percentage. S defines the roughing spindle speed, whatever S. R defines the roughing feed in Z. F defines the roughing feed in XY. B defines the finishing spindle speed. Since you are not doing finishing, okay, this is not applicable. J defines the finishing speed. This is also not applicable. Okay, in that way, you don't have to worry about these two. But whatever I given, you just do, it won't take into account. Okay, in that way, you just see G171, P75, S100, R75, F100, B1500, J1500. Anyway, these two will applicable for finishing. Anyway, it is not applicable. Okay, and as you see here, okay, as you see here, see here, G170 block, carefully understand all that you have to repeat in the same way. G171 also, R defines the roughing feed in Z, that means coming vertically, what should be the feed. F defines the roughing feed in XY, in XY how it should be and all that I have given. In that way, okay, F is F100 means when it is operating here, what should be the feed, that is 100 will be the feed per minute and all that. Now this explains how exactly the manual part programming has to be made for this type of profile. Okay, thank you very much for viewing. In the session 2, I will be explaining how it has to be done in Fanuc simulation software. Thank you very much for viewing. Thank you.